Thank you. Thank you all for coming, and thanks to Henning to give me this opportunity to expand on some of the ideas I also presented at yesterday's hearings to the FCC, field hearings in New York and New Jersey. So, I have not explicitly worked in resilient networks, but we have at NYU Poly been working on this notion of wireless cooperation for many years. And we've been looking at this notion of wireless devices helping each other to create additional capacity, and all the way from the physical layer up to the higher layers in the protocol stack. And as David Goodman, who is here, I'd like to quote him, he says, we want to build a network where the addition of any additional wireless device is viewed more as an asset to increase the capacity of the network rather than another device competing for scarce spectrum. So that was the basic idea of this notion of cooperation. So, so our focus was really on building capacity given this explosive increase in demand for capacity in wireless networks, which is called the bandwidth crunch, which is this doubling of demand for wireless capacity that we are seeing right now, thanks to smart devices, smartphones, et cetera. But you can essentially view the same ideas in the context of building robust cellular networks, which is I'll talk about. So when we are looking at it, I had a student, so let me just mention, Shahua was a student working on this paper, the urge to merge when cellular providers pool capacity. And we were looking at what happens if two cellular providers merge their assets, merge together. So, and we just started the work, and then this news came out that AT&T wants to merge with T-Mobile, which did not eventually happen. In that context, it was interesting. But we saw kind of an echo of that in the AT&T T-Mobile temporary merger after Sandy in the affected areas in order to provide better service. And the reason they were able to do this is because they operated with similar technologies, similar standards of wireless. And interestingly, we now have this opportunity because all the carriers are converging on a single standard, the 4G LTE. And this was not true earlier. And as a result, the whole concept of carriers helping each other or merging following a disaster is now become feasible. And this is what I'll explore, what are the advantages of that. So in Europe, similar things are going on for business reasons. And so what are the basic ideas here? What are the basic issues? If you have this temporary merger, you can share infrastructure, cell towers or whatever, and italics have emphasized the case where you have a disaster, so you may have to be sharing surviving infrastructure. Certainly you can share the spectrum owned by the carriers. And in order to either increase capacity during normal times or maintain capacity post-disaster. And again, mergers, of course, reduce operational expenditures and capital expenditures, but also reduce vulnerability because you look at the strengths of the two carriers. And normal times, any merger would increase revenue and profitability, and of course decrease competition, which is another issue that I will not address, or improve reliability, which is something desirable after a disaster. So, okay, so what are the two things we'll be looking at? So we're all familiar with roaming. You go to some city, maybe in some foreign country, and you need to connect to some other carrier in order to make phone calls. And, or you're in some region of the country where one carrier has better service than the other, then you may have to switch. And there are these roaming agreements which govern all of this. So one of the intermediate concepts we're looking at is why not extend this roaming concept? So, so following a disaster, you essentially quote unquote roam to other carriers during that period to establish your calls. Okay. And so another concept or related concept, do a slight digression here, is the issue of femtocell connectivity islands. So femtocells are like these small base stations which you can connect in your home, and these have not been very aggressively pushed, but they're available. And what if these femtocells were open to all users irrespective of whether you're a subscriber to that particular service provider or not. So you could then create these femtocell island connectivities in your neighborhood, even if the macrocell base stations, the big base stations were down. And this would be another way to provide connectivity and would make use of the fact that many people are now buying generators, have their own power supplies, and that would mean that you're less dependent on the generators in base stations. So, so this is another related concept we're looking at. I won't spend much time on this, but this is also a very interesting concept. So let me explain what happens when two carriers either permanently or temporarily merge their assets. So this is a very simplified example. There's a blue operator and a red operator. So the blue operator and the red operator are competing before the merger, serving the same area. And if you look at the edges of these hexagons, if you look at these edge of the blue cell here, you get poor service there. But if you are close to the center of the red operator, you are at the edge of the blue service, but right close to a base station for the red operator. So you get much better service if you could connect to this red carrier than if you were connecting to the blue carrier. So if you merge these two operators, what you can get is you're doubling the number of base stations, you're doubling the spectrum, because assuming each of them have the same spectrum, and these two doublings add up to a quadrupling of the total capacity, which in turn means that even though the customer pool has doubled also, each customer is getting double the capacity than it was before the merger. So this is a very simple thing. This is exactly what carriers are doing now, they're trying to do, trying to put more cells, buy more spectrum, but this has already been done in a sense. All the investments have been made, the base stations are up, and following a disaster, this quadrupling of capacity can always be initiated. Now, of course, in a disaster, you may lose many of these base stations. So, but if you lost randomly about half the base stations, you would still be able to maintain pre-disaster service because of this effect. So, as I mentioned, we're looking at two cooperation strategies. One is this FLEXROAM, what we call FLEXROAM, or flexible roaming, which is this enhanced roaming type concept, which we already have. In this case, the cellular operators hang on to their spectrum. They don't give it away, or they don't allow it to be shared, but allow users from competing operators to connect through their base stations. Okay, so this would just require faster signaling, some software changes. The second one is the one I was just mentioning in the previous slide, where you merge completely all the spectrum and the base stations. So, so we looked at these two strategies. We did some analysis using analytical modeling, simulations. We looked at actual base station locations around Washington, D.C. to see whether it would make sense for these two operators and what would happen if they merged. And our main conclusion was that if you did this fast roaming concept, which is a halfway house or a more conservative approach, you would get a 45% increase in capacity per customer. If you did this full merger, as I mentioned earlier, you would get a doubling of capacity or 100% increase. So, and of course, all of this would degrade correspondingly, depending on how much of the infrastructure survives. But there was discussion of different carriers using different backup power, for example. Some are going for more batteries, some are looking to fuel cells, some are going to use microwave, backhaul, others will depend on landlines, fiber optics. So the diversity of the technology being considered by the carriers actually helps us, because it means that depending on how this disaster hits, whether it's an earthquake or a storm, it'll affect different parts of it. And we could use this diversity to our benefit to provide service, because we know that if you are on a single technology and that went, everything would fail. But given the differences between the carriers and the way they operate the network, actually makes the system more robust. Some of the future work we are looking at is looking at other cooperation strategies, relays, stations, and other devices which help you bridge long distances to base stations, cooperation between cells, and another concept is energy efficiency. So if you only have, let's say, 8 hours of battery life in your base station, and there's a neighboring base station from another carrier with also 8 hours, how would you have the two carriers work together to extend the effective service in that area by load balancing between those two base stations? And then, of course, there's the issue of pricing, and how would you incentivize the carriers to do this? And there could be some game theoretic analysis or some regulatory changes which would facilitate this.